Chem 12, AP, periodic trends. Ding. Not all ions are created equal. Some ions are smaller than their parent atoms, but some ions are bigger. Why is that? Today, we are going to explore why one type of ion, called a cation, is generally smaller than its parent atom. First of all, before we go any further, what exactly is a cation? A cation is an ion that is positively charged. An ion which is caused by a loss or gain of negatively charged electrons gives an element either a positive charge or a negative charge, depending on what that element is. Most metals, like lithium and beryllium, are likely to lose electrons, in turn making them positive ions, or cations. Most nonmetals, like oxygen and fluorine, are likely to gain electrons, in turn making them negative, or anions. Now back to the main question. So why are positive ions smaller than their parent atoms, or atoms that do not have a charge? Well, the answer to this question brings us back to the concept of forces. Forces of attraction and repulsion play a crucial part in the size of an ion. A higher nuclear charge would result in a greater force of attraction between electrons in the nucleus. A higher number of electrons would result in a greater force of repulsion between these negatively charged ions. Let's take a look at lithium, for example. We already know that a lithium ion will result in a 1+ charge, so we know the ion is a cation. The formation of this cation will vacate the most spatially extended occupied orbital, which in this case is the electron in the 2s orbital. Once we remove that electron, the electron-to-electron repulsion forces weaken. Therefore, the forces of attraction from the nucleus have an easier time reeling in the remaining electrons, effectively reducing the overall volume that the electrons occupy. This process is similar to a fisherman trying to catch all the fish in a lake. The fisherman is the nucleus and the fish are the electrons. If one fish swims away, it's much easier to reel in the remaining 2 fish because there are fewer fish. This process happens for almost all other cations on the periodic table. But wait, there's one more interesting thing you should know about cation size. Take a look at this table of cation and anion size compared to their parent atoms. The cations are in red and the parent atoms are gray. Notice anything? Examine the alkali metals. As you move down the group, the cations and parent atoms are increasingly larger. The cations are still smaller than their parent atoms, but the overall size increases as we move downwards. This is because of the quantum mechanical model, which states that electrons exist in specific orbitals around the nucleus. Along with this model comes the idea of the principal quantum number. This number, we'll call n, dictates the kind of shell the electron is in. As n increases as we go down the group, so does the average distance of the electron from the nucleus. So, in conclusion, today we covered what exactly a cation is, why cations are generally smaller than their parent atoms, and the periodic trends in ionic radii. Thank you for watching.